Hello, algebra students. Mr. Lawrence here with a quick factor check. And the first type of factor you should always try, GCF, greatest common factor. I'm going to do two problems for you, explaining them in detail, and then there's one for you to try and see if you can get right. It's always the first type of factoring you want to try, okay? So, let's see here. I've got 10x minus 5. Well, the GCF is the greatest common factor. The factor, it's got to be common to both terms, and we want the largest one possible. Well, I think it's just simply going to be 5, and I think most of you would be able to identify that. 5 is a factor of 10, 5 is a factor of 5. There is no other factor of 5 other than 1, so therefore 5 is the GCF. So I factor out the GCF. Now remember, when you're done factoring by GCF, it will look like a distribution problem, like you should go ahead and distribute. Don't go ahead and distribute, but that's what it's going to look like, so you can tell what you're doing. All right, so here we go. I'm going to have 5 times the quantity of 2x minus 1. Now, if this looks like a problem to distribute, when I pulled that 5 out, I must have been using division, because distribution uses multiplication. I'm going the other direction in the order of operations. So I would have divided this by 5 and got 2x, and I would have divided the 5 by 5 and got 1. So it's 2x minus 1. Now the 5 comes out front. Okay? There you go. Now when it's more complex like this, it's still pretty easy. I'm going to find the GCF of the coefficients, the 24 and the 40. And I'm thinking that it's 8. If I'm not sure, I can list the factors of 24, 1 and 24, 2 and 12, and notice how I list them systematically so I don't run into any problems. So many of you just do it haphazardly. List them systematically. Now I'm not going to start at 1. No, Rithvik, you don't start at 1. I'm going to start at 24. I'm going to see if 24 is a factor of 40. If it is, hot dog, I have the GCF of the coefficients. But it's not, unfortunately. I ask myself, is 12 a factor of 40? No, it is not. Not with an integer or whole number partner factor. But 8 is. So 8 is going to be part of my GCF. Now, I need the GCF of the x's. Well, this is so simple, ladies and gentlemen. It's going to be the x to the lesser power. Yeah, because there's 2 x's being multiplied here, right? So x squared is a factor. Aren't there 2 x's being multiplied here? Mr. Lawrence, there's actually 6 x's. Well, yeah, if there's 6, aren't there 2? Can't I think about x to the 6th as x squared times x to the 4th, right? Well, in that case, see how there's an x squared there, and there's an x squared here. So x squared is part of my GCF. Like I said, it's going to always be the term with the lesser exponent. So for the y's, I've got y to the 7th here, I've got y cubed here. The GCF for the y's must be y cubed. All right, y cubed. Then finally the z's, I have a z and I have a z to the 5th. Well, isn't this z a z to the 1st? So z must be the GCF of the z's. So my GCF of the whole expression would be 8x squared y cubed z. So I divide each of these by the GCF, 8x squared y cubed z, and over here I'm going to get 8x squared y cubed z. And when I do that, I'm going to do 24 divided by 8, which is 3. Oh, I'm making a big mistake, aren't I? Yes, I am. I forgot to write my GCF out front. Silly Mr. Lawrence. Don't throw the GCF away. It's not an equation where we can divide through. We have to undistribute it. Factor out that GCF. Y cubed z. All right, so I'm dividing the left-hand side. 24 divided by 8 is 3. X squared divided by x squared, those cancel. I have y to the 7th over y cubed. Well, 3 of these y's will cancel with 3 of those, leaving y to the 4th in the numerator, right? And then the z's are going to cancel. Okay, now I've got to divide the second term. 40 divided by 8 is 5. X to the 6th over x squared would be x to the 4th in the numerator. The y cubes are going to cancel. Z to the 5th divided by z would be z to the 4th, would it not? There we go. Okay, problem number 3 is one for you to try. It's done the same exact way, but only you've got to find the GCF of 20, 35, and 50, and the GCF of x to the 8th, x, and x to the 10th, y to the 6th, y to the 9th, and y to the 4th. Go ahead and do it. Pause the video. When you're ready to see my solution, I will send it to you. All right, I think my GCF, here comes my solution, is, the coefficients is going to be 5. Of the x's, it's going to be x. Of the y's, it's going to be y to the 4th. I'll be multiplying that by 4x to the 7th, y squared, plus 7y to the 5th, minus 10x to the 9th, like that. And there you go. I just factored by the GCF. That was just a quick check for you, ladies and gentlemen. Please come get some help if you're not sure what's going on. All right, Mr. Lawrence signing off with your quick factor check. Have a good night, everybody.